Hi, everyone. Thank you so much for joining us. My name is Angie, I'm representing SFE LA today, New York. And Together with the Carbon Leadership Forum, we are super excited for you to be joining us for this first of its How It's Unmade conversation. You just go to the next one. So super quickly, just wanted to plug some upcoming events we have in September in LA hosted at the Walter P. Moore office. We're having our LA Forum, which is once a year. And then in October, for a to be determined date and location, we're going to be having our Fall City Walk event, which was extremely successful at 270 Park Avenue in the spring. And so we're looking forward to that. And make sure to add the our email or subscribe to our LinkedIn page to get updates as we go forward. And If you are excited about these kinds of events and want to see more of them, if you would like to consider your company becoming a sponsor, we would always appreciate that. So you can just send a note to the SFE emails and we can send you information about tier levels and things like that to see what's possible. So with that, I'm going to turn it over to Aria, who's wearing many, many hats for this and is kind of the reason this event is happening. So Aria.
Yeah, thank you. Yeah, so hi, my name is Aria Maskell. I am a graduate facade engineer with Buro Happold out of Los Angeles office. I am also the co-chair for the CLF LA Hub, and I've aided in developing some Society of Facade Engineer events this last year as we extend into the Los Angeles space. And I will be your moderator today. So before we kick off this first meeting, I wanted to give a little plug into the future CLF events here in LA. So we are really excited to share that we're developing an exhibit and hands-on workshop around bio-based construction materials and methods for this fall. So this workshop would be done in collaboration with a Regenerative Rebuild Collaborative, a group of architects and engineers working to foster the adoption of bio-based materials, especially in areas impacted by wildfires. We will be sending out a brief survey to gauge interest and receive feedback around the event to confirm details. And we are currently imagining this to be an in-person event in Pasadena, California for the weekend of September
Oh,
12th,
no,
though that will
no.
be
Inside.
confirmed later on. Um, and then at this workshop, participants will be able to visit and exhibit on a variety of bio-based construction materials and methods, and then ultimately get a chance at building Adobe bricks, which will then be donated to the local fire rebuild projects. So a really exciting opportunity here in LA in September. So, and now let's kick off this How It's Unmade event. Um, So welcome to our first Society of Facade Engineers and Carbon Leadership Forum crossover event. For this webinar, we wanted to approach this concept or approach this with a concept that, really heavily intersects both groups, but is also future design oriented, which is where kind of this How It's Unmade theme came to fruition. Some of you may remember CLF's presentation from about a year ago, titled How It's Made. Today's talk should provide insight to the other end of a facade's life cycle as we dive into various aspects of that deconstruction. We will have three speakers, Tania Cortes, Sophie Pennetier, and Leila Behjat, who will each speak on their respective expertise in a way that narrows the focus as we go from kind of a general proactive design research to material-specific disassembly. So I'm going to stop sharing and I'll introduce our first speaker. Today, we're going to start off with Tania Cortes, a senior engineer with Buro Happold on our facades team, who has conducted extensive research and project work on design for disassembly, adaptive reuse of existing building envelopes. She will start with critical insight into proactive approaches for the idea of designing for disassembly, why it is essential to the success of a project, and then how to start understanding and breaking down all of the complexity that happens within this realm. So welcome, Tania.
Hey everyone, thank you very much. Thanks for having me. Thanks for inviting me to speak here today. So today I will be sharing some of the research that our global facades sustainability working group has undertaken on design for disassembly, why it matters, where the industry stands today and how it can extend the carbon value that it's already embedded in facade systems. So as facade engineers, we spend a lot of time and a lot of effort designing systems that are efficient to manufacture. We talk about ease of transportation and how are we going to install this facade once it gets on site. But we actually rarely ask ourselves what happens after that facade reaches the end of its service life. Is it actually designed to come apart just as intentionally as it was designed to come together? And the answer, sadly, is usually not, because our current practice actually relies in an industry where we have a linear model. So essentially, as facade consultants or as architects, we design systems, we install them. Hopefully, they remain in use for 30 to 60 years. And once that building changes or it reaches its end of life, we encounter demolition, and materials and components end up in a landfill, or maybe in the best case scenario, they go through selective recycling. But in any case, we see how they lose their value pretty quickly and they are discarded. So that's actually pretty critical, and this matters a lot because first, from a carbon perspective, reusing components avoids manufacturing new ones and therefore sourcing raw materials. And that helps actually preserve the embodied carbon that has already been invested in components that were manufactured. From an adaptability perspective, we don't really understand that buildings are not static entities. Buildings are always changing, and facades can become obsolete if they cannot keep up with those changes. And if they become obsolete, it's very easy that they get discarded. So we need to understand how facades and buildings in general can also adapt to the changes that we face regarding technology, regarding code, etc. And at the same time, we are facing an increasing resource scarcity that has actually been flagged in the case of critical materials by the European Union and the US government. In facades, we use a lot of critical materials. We use aluminum, we use metals that go into steel alloys, titanium, high performance glass, and such materials should actually be viewed as valuable assets instead of just waste. And finally, the last is that regulation thankfully is changing, and circular economy practices are actually becoming more normal in our industry as we push towards this direction. So essentially, when we look at design for disassembly, what does that actually mean, and what would that mean in the context of facades? So in simple terms, it means that we are going to design facade systems so that those components and that those materials can be recovered without destroying their value. And we will design them to allow to remain in use for as long as possible. Now, when we look at a circular economy diagram, we usually see the butterfly diagram with a lot of loops. An important key takeaway that I would like to highlight today is that not all of those circular loops are equal, or they will not deliver the same value. We usually focus on recycling, and recycling certainly has an important role, but it should actually be the last option because it often destroys much of the value that was already invested in that product. And actually, if you look at this diagram, the greatest value lies in extending the life of products through repair, refurbishment, reuse, and remanufacturing. And design for disassembly is actually what makes these higher value loops possible, because it allows those materials and those components, those systems, to actually go through those higher value loops rather than simply reducing them at the bottom to the raw material recycling loop. So that brings us to think that ultimately design for disassembly changes in the way that we think about facades and the way that we think about systems. So rather than seeing facades, building products, materials as just consumable products that have a single life, we should think of them as material banks. Understanding that a material is actually a repository of valuable materials and components that can continue creating value beyond the life cycle of a single building. So in other words, just because the life cycle of a single building is over, it doesn't mean that the materials or the components that lived in that building need to reach their end of life. So as a facade engineer, we always have to question ourselves, If this is vision, what does it actually look like in practice? And we can talk about the principles of design for disassembly. They don't actually prescribe one construction systems. Facades have so many typologies, so many different materials, that rather we need to understand it as a number of design principles. The one that we talk about the most is reversible connections, mostly to ensure safety construction and that we can enable reuse without compromising the materials. We talk about material selection and recovery, how we should think beyond embodied carbon at installation and actually consider retaining the materials value at the end of the building's life. Also, other design principles that are important are the system separation and modularity, because that would allow those components to be repaired, replaced, upgraded, refurbished without actually disturbing the entire facade. So especially when we talk about long-term adaptability, that becomes very important. Life cycle thinking, especially regarding embodied carbon, encourages us to design not only for installation, but for maintenance, adaptation, and eventual recovery, again, to retain the embodied carbon of those components for as long as possible. And then lastly, the one that is maybe not as exciting and is usually overlooked is documentation. It's very critical, actually, because we need to keep records and information of how that facade is going to be disassembled, because we want this component to live for as long as possible. So in 30, 50, 60 years, the people that are going to take it apart are not the same people that put it together. So we need to maintain accurate records, material passports, end-of-life documentation, assembly and disassembly, etc. So again, how does this look in practice? And a facade engineer, how do we actually apply these principles? We actually have a lot of guidelines related to design for disassembly. While each of the standards that I have on my screen right now might differ in scope, they actually all emphasize many of the same principles that I spoke about on the previous slide regarding specific guidance of individual aspects of the construction. So we are not starting from scratch. We already have a solid technical foundation. We have, for instance, two very important ISO standards, which are at the top of the table. The first one is 20887, which is where we should typically start. It's a standard that sets out the core principles and the strategies for design for disassembly and long-term adaptability. And it basically provides us with a technical basis and reference for defining and justifying why design for disassembly should be part of a design brief, specifications, project standards, etc. Then the second ISO standard that we have is, maybe it doesn't look as comprehensive, but it's actually very relevant because it's a framework of sustainability indicators and end-of-life performance. So it's actually very useful because it justifies the integration of design for disassembly strategies within recognized sustainability metrics. In terms of European standards, we have the European standard for EPDs. And the important part of that is that it gives us the modules C and D, which in a whole life carbon assessment, it also justifies the benefits of deconstruction from an embodied carbon perspective. And then our team, because we are a global sustainability team at Happold, we have also analyzed the regional guidance that we have in the UK, in Germany, in the Netherlands, in the USA, because we work in different regions and we need to understand what each region has been doing, the latest discussions regarding circularity and disassembly. So we also have guidance for every different region. Then if we move forward towards sustainability certifications, which are also very important, they're voluntarily usually, but we need to understand how these ideas are reflected on sustainability certification systems. Here is where the picture becomes a little bit mixed. Some systems, such as the Building Circularity Index, which was developed by the government of the Netherlands, it places a very strong emphasis on design for disassembly, where it is mandatory. They have the Material Circularity Indicator and the Loosenability Index. And as you can see in this table, it actually takes all of the marks. And we have others like BREEAM and DGNB, which is from the Netherlands, and they include design for disassembly, they define it, and they actually reward it to varying degrees. And then we have other certifications which are widely used, for instance, LEED, which is widely used here in the USA. And it does not explicitly recognize design for disassembly, but we know that there is awareness through, for instance, innovation, waste management, etc. So awareness is clearly growing. There are some regions that are definitely more advanced than others, and it is important that we learn from each region and to understand how circularity is incentivized across the industry, because those incentives are what, as facade consultants, might help us shift towards circular practices. So in a few words, there is actually no shortage of guidance, and that has been the biggest takeaway from my research since I did my Master of Science and now working as a facade engineer in the industry. We know how to do this. This is not a technical barrier. We actually have an implementation challenge, and that is because the facade industry looks like this. There are so many stakeholders involved. It's a very complex supply chain. There are different responsibilities and different incentives being involved. And there are so many questions that arise, which are, is there even a market that is willing to buy reused facade components? Who will own those materials once a building reaches the end of life? How do those warranties apply to testing and to reused products? Who is taking the risk? How do building codes accommodate them? And perhaps more importantly, who is going to be responsible for documenting how things are taking apart so that in 20, 30, 50 years, we can actually recover those materials. So there are a lot of questions that the multi-stakeholder industry needs to answer, and risks and warranties. And it's just that the general practice needs to shift because we're currently in a linear model, and it's very difficult to implement this in a linear model. So as I wrap up my chat from today, I would like to leave you with 3 key messages. The first one is that why do we design for disassembly? It's not for demolition. It's actually about preserving the value of materials so that they can remain in those circular loops. Design for disassembly is a strategy that will enable that. Without design for disassembly, we cannot achieve circularity. Why? And that is my second point. It's because only if those systems are designed to be taken apart, or in other words, if those systems are designed to be recovered, that will allow us to preserve the value and the embodied carbon that's already invested in those facade materials and components. And finally, even the most sustainable material cannot be circular if the system that it's embedded on is not designed to come apart, which brings us perfectly to the next part of today's session with Sophie and Leila. So today I talked about how we design systems to keep materials in circular extended loops, about the guidelines that we have and where the industry stands. But now I want to give time to Sophie and Leila to tell you all about materials themselves and why material innovation is the other half of the circular economy. Thank you very much for having me. I really appreciate this space, and we'd love to hear your questions. Please feel free to send us an email. Again, we are a global working group, so we are collaborating across different regions from Buro Happold.
Yeah, thank you so much. That was absolutely fantastic. Please, anyone in the audience, if you have any questions, now is also a wonderful time. Ask them. I actually have one, if that's all right. You spoke a lot about, this is very complex idea in a way that narrows it down and creates a bit better of an understanding of this complexity. What are some key elements that you found in your research that seemed to be simple at first, or seemed simple in theory, that expanded and kept growing or snowballing into, more of that complex that was maybe a surprise to you?
Yeah, I really like this question because I think the issue, I'm going to go back to this diagram because I think this illustrates it really well. I think the issue with understanding circularity, and especially when we talk about the reuse of components, is that it's the availability of those components. It's a bit, in simple terms, if I say it, it's like when you go to a thrift store, you don't know what you're going to find. You basically buy based on what's available, and you might walk out of there with maybe these random things that you were not expecting to buy. And I think that's one of the what I found by like because we interviewed like product fabricators, facade contractors, etc. It's just that you don't know what's going to be available in the markets to be reused. You will have to do urban mining. And again, where is all of that documented? Where can I see all of that? Some regions are a bit more advanced. For instance, in the Netherlands, there is a public database for urban mining where you can see which components can be reused because they actually integrated into their legislation that new buildings need to have a certain amount of reused products. So it's again the question that I have here at the top: is there even a reuse market? What is the availability of those components in that reuse market? We don't know which building is going to be demolished. So there's a lot of uncertainty, and that uncertainty comes with a risk. And those risks might not generate value the way that our linear economy works now. So that's definitely a big challenge. I don't know if that answered your question.
Yeah, definitely. That was fantastic. Yeah, I think we can learn so much from other industries and other regions as well. I know like you had the standards lined up that showed different successes that other regions have had within those standards of designing for disassembly. So I think that's absolutely a fantastic opportunity to start this and integrate it more into the US side. Awesome. Are there any other questions before we move on to our second speaker? All righty. Thank you so much. Okay, so our next speaker is going to be Sophie Pennetier, who's the founder and CEO of Digne, with 18 years of experience. Sophie's development in innovative glass products and circular solutions provide the basis for her exploration with us today as she dives into design for disassembly with the end of life for curtain walls. She will provide insight into current programs locally within the US and how they can impact the disassembly and reuse process. So welcome, Sophie, and thank you.
Thanks, guys, and thank you so much for hosting me once more with CLF and SFE. Really great groups, and great to see lots of friends in the room. I congratulate them for their persistent work. So I'll speak about two things. One, I'll speak about some of the effort started 5 years ago when I used to work at Enclose. We even have some Enclose folks online right now. And I'll then follow up in a second part with some of the work we've been doing since. So you might have seen this in the SFE presentation that with Enclose, we looked into circularity of the curtain wall units that Enclose manufactures, installs, and also repairs. Because whenever Enclose would have a call, say glass is broken by another trade or user, actually the contractors that actually install know how to maintain the system, such as changing the glass. And so we looked into ways to either operate in closed loop and opportunity also for open loop recycling. So I would say to anyone that wants to change things, just start with pilots and they are trying it yourself. If you don't have access to, an acoustic unit from an acoustic mockup that you have here on screen, you can just go to your nearest Habitat restore and get a window and just like open it up in your parking lot if you want. So with my colleagues, former colleagues at Enclose, we looked into the more typical deglazing in vertical state as well as horizontal, keeping track of timing. So labor is going to have a huge impact on the cost associated with unmaking windows and curtain wall, as well as the level of contamination. So if you want to go fast, sometimes you might have to, there's a risk of damaging the materials, which could actually reduce their reuse or recyclability potential. For instance, on glass, as soon as the glass is broken inside, it's a little harder to bring it back into a full window. This is possible, but it's a lot of roadblocks. However, you can always downcycle it to insulation, abrasive, and such that I'll talk about. So lots of potential. So there's always going to be this balance between time and contamination level. Same for aluminum. There's a lot of amazing work by the Aluminum Extruder Council looking into circularity of aluminum extrusions. And several cast houses around the US would accept painted, anodized, or even a bit of silicone traces. That's not a huge deal for recycling of extrusions. However, the stainless steel fasteners might be an issue. So that is also labor intense. So when you're looking at the dollar value, the value proposition of reusing or at least recycling those materials, there's always going to be a trade-off versus speed and value. So here, the idea that you just saw previously on the screen was brought into an automotive glass recycling facility. And so we were able to separate glass, PVB, spacers, and such, and have them recycled, downcycled into their highest reuse diversion potential. So as you're all saying, there's lots of needs for collaboration with the people that are making, and they're like the best help and the best to help us devise different tools, accesses, and design that are unlocking those opportunities. So it's a good moment to bring in architects and consultants and such for them to hear what they can do today to change their designs. For instance, in that specific case, whenever you have vertical blades, vertical near your mullions, you start to create some blind conditions where you need L-shaped tool to go deglaze your units. That would not be an issue if you just had lesser difficulties to access those. Or where are those things? You know, there's not one size fits all. You know, in that specific case, you have a horizontal to vertical bolted connection, fastener connection. And if that connection is in front of the water line in your curtain wall, you might have to anticipate that you cannot come in the field that fix all of those. So you'd have to possibly dab those sealants in fasteners and sealants to really maximize the performance and really have a long-lasting system, as well as optimizing, for energy loss or such. So, at Facade, we're at this interface of operational carbon and embodied carbon. And so, the pie is 2/3, 1/3, 2/3 operational, 1/3 embodied. We still need to make systems that don't leak. That's very important. So all that creates multiple pathways for the glass. Most of it today goes to landfills. So the task we have is to at least start to divert it. There's a lot of work in the concrete work as either cement substitution or aggregates for some exterior civil works. There's also a lot of innovation in roadbed integration. And then most of the work I do is turning glass into either abrasive, road beads, or insulation, glass insulation. However, these represent market splits. So they're not necessarily gonna, a window doesn't make necessarily a new window. This is why we operate in the space of trying to keep the glass unbroken as long as we can to really minimize contamination. So let me show you a little bit, a few examples. Before I do that, I forgot there was this slide. All those workshops at Enclose were also informed by tremendous leaders in the space, Laura with Walter Pimore, Lisa with USC, and my colleagues at Enclose, to name a few, as well as year after year, bringing on more architects, more contractors, and also deconstruction leaders. Some of the feedback was, we need policies, we need standards, but they're not going to save us yet. So if you're a member of the National Glass Association, you have the opportunity to go to the Hill, talk to House and Senate representative and trying to see what piece of legislation is in the pipeline that would allow for diversion of glass or recycling of building components. That's going to take time, and you can see it's a really long road. So looking at little pilots that you have around you. If the facade is too hard to access, look into opportunities for interior glass. So this is our office, actually. Well, I'm Enclose's office in the Bradbury building when we had 2 white boxes when we left the office. And so where we were able to divert furniture, metals were recycled, the glass itself has no taker. And so pairing our deconstruction company with our recycler was the next step. Trying to find somebody that would buy this material just to dispose of it. That is going to be this next step. We tried a pairing, didn't work. Tried the next pairing, didn't work. But the third pairing, that worked. And we're going to talk about it a little bit in a second. So really looking at any opportunity for a pilot. I'm going to slow down a little bit now and talk to you about another pilot that is sponsored by the National Glass Association and the Aluminum Extruder Council that is contracting Digne to perform an end-of-life study. So module C and D that were just mentioned by previous speakers. This project is a parking garage in Rochester, Minnesota. And the glass itself, as well as the materials, were recovered. Now, the methods of recovery was such that the glass was broken on site and then raining down at the interior of a net to a place of collection, and then brought it into Infinite Recycle Technologies the pipeline. So the idea was that the people would just bang the glass, which is probably not the safest thing to do. And then a third of the glass was recovered. And that is really due to the means and methods. So what can we learn from, I mean, a third of the glass recovered is actually better than any of the buildings that you guys designed today. This is fantastic. Let's try to aim at better. So we're learning from this that, we will publish a more like in-depth, but really the 6 little quick cliff notes are early owner involvement as well as GC means and methods support is going to be key. It's not enough to just say guilt trip people, in doing things. If you can actually help the GC speed up their schedule, actually removing large units would have been faster in that specific project, as well as enhancing safety. That's going to be big deal for GCs. The system is going to be driving the recovery rate. So whether it's gasketed or cooked in with silicone, you might have different times of labor, for recovering the system. So always something to look at. Whether the glass is tempered or not will enhance its capacity to be handled, and also the weight breaks on site. So this is actually one of the storefront units we had that was tempered, unlike the rest. And finally, job site context. We may as well have studies from Europe. They're fantastic, or studies from other cities in the US. They are super different from the winter arriving in Minnesota, or the labor rates are completely different from coastal markets. So it's really going to be specific to the recovery of these facade as it's unmade is going to be different from other contexts. So here in Los Angeles, we have now completed this little local program where we're nearing 200 tons of glass recovered for interior partitions, thanks to our partner IRS Demolition, who does interior partitions. And so today this is sent to abrasive, insulation, and such. And we're piling up. So we have large containers full of glass right now that is downcycled into abrasive. We're extremely happy that it is going out of landfill. However, we need to find ways to further incentivize the recovery of the glass. This is why with Digne, we're developing solutions which include remelting the glass in order to sell it at the actual cost of a sheet of glass. It has a third of the carbon footprint of an infill glass, so it's lower carbon because it's powered by solar PV in sunny California, so it's kind of nice. And then we can produce really large sheets for integration into your facades. So we have an active project with Gensler and some pipelines with other architects. And we do also have pilots. So we have a chapel in Arkansas and a pilot in Long Beach. We are backed by the LA Clean Tech Incubator and the USGBC California Net Zero Accelerator. So these are some of the products we are selling. And I would like to just take a moment to pause on what leadership looks like. Well, leadership was the procurement of small items, such as this lead plaque by Walter P. Moore that is now at the top shelf of their office. Our best sample is top shelf of one of the most important, thank you, Buro Happold too, but engineers in the city. So it's very fantastic. And that's leadership, as well as the Glass Tech Award that we produced upon commission by EOC engineers 2 years ago. So leadership finds itself in multiple ways, and just facilitating the recovery by those commissions has been key. So our more current project, we are recovering this little storefront in the Bay Area, as well as those glass blocks, and we're going to make testing on it on the glass that we'll advertise sometime in the future, related to reprocessing external glass. We are also recovering 7,000 square feet of interior partitions that are spotless. They were just installed before COVID in this building that needs they need to go. And so those are perfectly new doors. And this is not a sales pitch, but if you're in the market for 7,000 square feet of gorgeous glass partitions, we have 2 already coming to another project, but the vast majority of them are still looking for adoption. And so if you're looking to put them anywhere in California, just reach out to us. I'll be closing in with a few things, a few tips for pilots. You know, some folks online right now, we're trying to get pilots moving, and sometimes things don't work, but we're harvesting knowledge, we're harvesting connections, and there's a lot of things. So any size matter. That's what she said. The pilots itself is a success when we can learn from the stakeholders, learning, you know, everybody might point fingers at each other, but it also takes a miracle at every little step along the way. And if everybody thinks they're negligible, we're going to get nowhere. So any little pilot is great. Get friends with the contractor, the GCs, if you can find a way to divert materials, you know, and meet their diversion rates, if you can help their means and methods and schedules, this is going to be your best asset. And they've been, in my experience, the GC has been the absolute best at unlocking our firm's success. If not, befriend the demolition or the glazing crews. They're doing retrofit, they are doing white boxing. So just tag along and just see how they're doing. Number 4 is listen. Shut up and listen. Like really seeing the roadblocks, what are important for those stakeholders, and guilt tripping people is leading nowhere. And so really listening is going to be huge for unlocking all those pilots. Focus on roadblocks one at a time. Keep in mind that everybody likes a good deal. Like, I bought my car secondhand. There's also people that are actually ready for faster and cheaper glass partitions. So that's something that you can put ahead of them. And yeah, every project is an opportunity. It's not a matter of if you're going to be successful. It just might take time. You might get to the next one, but at least you can harvest some knowledge. So in closing, I want to show you the rate of recovery of post-consumer architectural glass across London, New York, and LA. The choice of color is not just by chance, but I just want to show you something. London in 2023 or thereabout, according to my personal source, was in a figure of roughly 30 or so tons of recovered post-consumer glass. Did 10x, actually 12x the year after. And then a few years later, New York is going following that trend. So last year, New York City, thanks to the effort of Sydney Meister and this group of leaders surrounding her, they achieved 272 tons of glass, US tons of glass recovered from buildings. And they're also going to 10x next year, or thereabout. We'll see where they land. And we are about to surpass New York City here in LA, and we're very proud of it. And I'll wrap up in telling you that a little bit of competition never hurts. There's a cool thing coming from England, and if you can just have coastal markets trying to compete against each other, I think this is always going to help. So with that, here's my email, reach out to me. And if you need any help on pilot, feel free to reach out. Thank you. It was fast.
Awesome. That was absolutely fantastic and really insightful into especially some of the comparison that you did between like the waste, the embodied carbon, and the logistics. I know like that side was a very clear, at least to me, tangible way to understand some of those different factors that can really play a part off of each other. Does anyone have any questions? Move on. All right. Well, I think I am just going to build on one of my questions, then we'll go on to Leila. But like what I just said, have you found that there is a strong crossover between low embodied carbon materials and construction methods, as well, or with this design for disassembly and glass reuse, or have you found that they often contradict each other? I know that you said there's lowering by about a third, or for the glass panel because of the PV and solar use here in Southern California. Have you found that there's a strong crossover, or do they often contradict each other? That
It will be specific to the location, the methods. We are not at the scale that we can actually be apple to apple. So that's always something to be very careful when you compare products. What we do is glass that can be 8 feet, sheets, 8 feet long in terms of sheet. It is less carbon, yes, but not to the scale that the large float lines do. So I'd say I would be careful about comparison. But I would remind you that if you even go and look at Enclose's EPD that I contributed to, the largest carbon footprint of these materials is when they're in the oven, let's say.
Yeah.
So as soon as you can offset some of that energy, the transportation is not huge. It's really the energy. And since it takes less energy to remelt glass than melting the raw components that make glass, there's definitely a trend towards low carbon. So yeah, that's there's a relationship, but it's always going to be super specific to your recovery states. As long as you don't heat up stuff, you should be on the good side, or not too much, or electrical. Anyway.
Yeah. Perfect. All right. Well, thank you so much. All right. And now for our last speaker. Our last speaker is Leila Behjat, who is the Director of Material Ecology at Parsons Healthy Materials Lab, where she curates collections of healthier, low embodied carbon construction products and design methods to achieve regenerative and toxic-free spaces. Leila heads the lab's partnership with the new European Bauhaus and is co-founder and general manager of the Healthy Materials Lab in Germany. Today, she is going to take us through bio-based materials and their impact to both human and global health, as well as their critical influence in the disassembly circularity world. So welcome, Leila.
Thank you so much. Thanks for the invitation. I'm really delighted to be part of this conversation. And I have to admit, I have a whole bunch of questions to my fellow speakers, but I thought I'll leave the space for others, but I hope we can continue this conversation. So I'll allow myself to, oh, sorry, this won't, okay. I just want to introduce the lab a little bit. We're a design research lab that was established to support and accelerate the building industry toward healthier, low carbon ways of building. We're an interdisciplinary group. We're from a variety of disciplines, and we always collaborate with colleagues and fellows. Our goal is to improve the health of individuals, families, communities, and the planet by centering human health in every decision of design and construction. And we share research, tools, and strategies for the design and construction of the healthiest low carbon and hopefully also sequestering materials available out in the market. So over these last 11 years, we have collaborated to create healthier homes for over 500,000 people, and our courses and resources have educated over 100,000 architects and designers. We also do demo projects to show that healthy building is possible today. Like here in the PA hemp home, that was a hemp lime renovation in the US. we collaborated with a community housing provider, Dawn Services, in Newcastle, Pennsylvania. And this rather small affordable home renovation still then became the example used to change the international residential code to include hemp lime as a viable bio-based insulation option. And here in Providence, Rhode Island, we accompanied architects, builders, and also the board of a community music school to make a healthy interior space for the first fully cross-laminated timber building in Rhode Island. So in these following few slides, I will strive to cover a lot of ground, spanning from the impact of chemicals to the emergence of bio-based construction products, and then connecting this all to the healthier design principle of design for disassembly within the context of facades. So we know that our industry is accelerating climate change, causing toxic burden to people, polluting our ecosystem, contributing to the triple crisis. And we also know how we can change this. The innovation in synthetics and industrial developments are only a few generations old, but as I think all of us in this room know, it was very convincing. And as a result, construction products are made from the petrochemical byproducts of the petroleum industry, which means that our interiors and exteriors are made from petrochemicals. There's a new report from Denmark that shows that products contain PFAS throughout industries, including construction products used in facades. So in turn, prioritizing the use of bio and geogenic materials is an effective way to achieve decarbonization and detoxification goals for the betterment of ecosystems and humanity. And we see that the industry is responding, offering more options and products every year. Facades are especially important to consider as temperature, weather, and wind drive the degradation and aging of cladding, and particles fall out, leach, or off-gas naturally, and then it's intensified through this process. A facade mediates heat, and in the context of climate adaptation, that then is intensified by the increased and prolonged heat impact on the envelope. I'm showing here emissions from interior materials such as laminated flooring, etc., through elevated temperatures, which then begin off-gassing substantially, and the elevated temperatures here are in the range of 100 to 113 Fahrenheit. So emerging data shows that heat doesn't just stress the building, it changes what the building emits. And then as temperatures rise, some semi-volatile compounds can shift into fully volatile behavior, meaning materials can become more emissive in ways that are not captured in standard test conditions. In our collection of healthy and regenerative products, there are some available options that can replace typical 20th century products that are increasing these issues and burden our environment. So the question is that is at hand today is, of course, whether these healthy bio-based facade materials that we want to move towards can also cater to the need to be recoverable and support design for assembly by basically making use of joinery that avoids adhesives. And there are great options out there. You can find some on our exterior and structural material collection. And I want to now zoom into two examples with you in the following. So straw building, meaning using the byproducts of food production for construction, is obviously not new, but we are seeing that we are on the cusp of its acceleration. Sorry, I keep getting stuck with the slide projection, sorry. So the Lithuanian-based company EcoCocoon has been modernizing the practice of straw building. Their award-winning panels consist of 10% FSC certified wood and 89% straw. All of their pre-assembly cases can just be reversed and disassembled. The manufacturer states that in their digitalization process, from planning to production, it is designed for this. And this 12-story residential building that you see here on the right is made from a glulam structure, and then it has this infill with the straw walls, with the thought that it can be disassembled in the future. The process is prefabricated and modular with several standard straw walls components like lintels, etc. And what I think is so interesting in the combination of this with the intelligence of material is that the straw is densely packed, the oxygen inside is limited, and then thereby inhibits microbial growth and also limits the rate of decomposition and helps with fire retardancy. So it decreases chemicals. This logistics and distribution facility in Lelystad, the Netherlands, was designed by the Danish design firm Henning Larsen and executed by a Dutch contractor. The building integrates 40,000 square meters of EcoCocoon straw panels and has the same concept for the future. And then the second material, cork, is another standout material. In itself, it's a porous, lightweight, it avoids resin and is breathable while being fire retardant and impermeable to liquid and gases. It's thermally insulating and fully biodegradable, which makes it very ideal for different applications, such as insulation, flooring, but also cladding. And a great example is the Cross Cabin built in Austin, Texas. It's by design healthy and recoverable. It's a cork facade, a CLT frame, and hemp insulation. It was designed and built to not trap toxins and not block disassembly. What I thought was interesting was that it was built for under 430,000 and also calculates carbon negative. So this building called Cross Cabin's cork facade is fastened, not glued. It's screwed directly through shiplap panels into the CLT structure. The seams overlap and hide the fasteners. And so this dry monomaterial assembly with 2-inch thick cork cladding is fully removable and repairable and combines this aspect of disassembly and material health really beautifully. Just one interesting fact is that cork is very versatile and it can also be used in wet areas such as showers. Anecdotally, I really wanted to include this, although it's not bio-based. This is an historic example. This building was made of cast iron parts in Lower Manhattan. It was built in 1849, and it was designed for disassembly. And then it was indeed taken apart in 1971. So this idea really has been existing, in our construction history for many decades. So in conclusion, facades that are bio-based and can be taken apart and reused are the matter of the future. They decrease emissions, they help heat adaptation today, and then do not add to resource depletion and landfill tomorrow. Just a little bit about some of our resources. If you want to learn more, you can visit our material education platform for a full certificate program or just shorter master classes. We tell research-based stories about the material world in our podcast, Trace Materials. And we have this publication called Material Health Design Frontiers, with a collection of examples and strategies for healthy, decarbonized, and circular design and construction. And with that, I come to the end, and I'm really looking forward, hopefully, to a conversation now. Thank you so much.
Yeah. Yeah, thank you so much. That was absolutely wonderful. Yeah, please feel free to jump in with any questions. I know we're close to the 1 o'clock hour, but if any of you guys want to or can stay on for a couple minutes longer, then that would be fantastic.
If no one has a question for me, I have a question for my colleagues.
Perfect.
Yeah, may I?
Yeah.
Because I was throughout both your presentations, I was wondering, just about the role of material passports and how you view that. Because that's something we, think through often, and are so curious how that can be enforced more. Whether you see that there's a, whether these could be part of the solution.
Wanna go, Tania? I have a few thoughts.
Sure. So I think that's the part that people are not very excited about. It's the documentation, right? Because what the objective of design for disassembly is that those components are kept in use for as long as possible. So the people that put them together are not the ones that are going to take it apart. The people who designed it are not the ones that are going to be involved in the deconstruction. So documentation, especially material passports, are very important because they are like sort of this manual that will enable deconstruction to happen in the future in 30, 60, maybe 70 years. There are some, I know that the European Union, it's a region that it's way ahead of us regarding that, and they do have certain guidelines, and they even enforce it in some of the certifications that we overviewed during my presentation. But that is something that definitely the US region can learn from, because it's not really enforced, but it is very important.
Yeah.
Yeah, I will tell you that even for glass, we see in the glass circularity space, there's lots of really great work by this PhD that just graduated. She did some work with AGC. They looked into the concept of, well, when you're gonna just recover a piece of glass, like, is it gonna be broken up? So do you start to have like parent and child like passports? Here in the US, with what we have to deal with, maybe your next best thing is tempered glass has a little bug. So if you're a glass nerd, you can go to the bottom of a piece of glass and you see this information. You even have this in your car. And then the spacer inside an IGU has quite often a code that can refer back to the manufacturer of that insulated glass unit. So those things exist. And when you look into like curtain wall opportunities, I mean, yeah, I don't want to speak for my previous employer, but there are so many opportunities to document the work that actually was used to procure it, right? So these things are in the hands of people that buy them. They're there, and they have to be destroyed by the people that don't serve, if they don't service them ever again. So there are opportunities, so much opportunities. And in my case, on the Mayo Clinic project, we had to go down and find this kind of old school, shop drawings. So it's really hard to get much information either. So yeah, there's definitely potential there. I would so recommend people to work with the market, what can you achieve without getting pushback because it's small work that people don't want to pay for.
Yeah. I find it so interesting because material, from looked through the lens of the Healthy Materials Lab, material passports are like the continuation of where we start in terms of a composition of a product. So what is the product made of? What is the building made of? And to your point, Tanya, how can it, then once we take it apart, how can we reuse these parts? It would be the same as, recycling a product. I'm just so curious to see more of that coming out into the market and becoming more routine.
Leila, I want you to know that today, when a building is procured, there's all sorts of submittals like certs. You have to actually submit your certification for most of the metals. You have all like submittals for the sealants, any product that you have. That is typical process nowadays. That's a great place to start at no cost.
Agreed.
Yeah. I have a question for you. This is so fascinating to see your work in like trying to avoid, PFAS and possibly cadmium, all those kind of things that are we know now, create cancer. So I would have you ever been in that situation where, a product that is not really protected the same way we expect new products, such as for fire or for mold or for these things? Like how do you work with the fact that you have to sell, that it's going to take more maintenance? Like, how do you convince people that this is good for their health, but yet they might have to do a little more work and maintenance,
Yeah.
How do you deal with that?
It's always, there's always obviously the possibility that there is a lot of resistance, but to be very honest, the reason why I brought in the heat impact, and it might have felt like I'm detouring, but it was really exactly to that point that even if in the general context we might feel like, well, it's too expensive, it takes too much maintenance, it's just too different. If that still feels like valid points, I really do think that with these increased climate conditions, in particular heat, we will, I'll say, be forced more and more to really think differently about the products that surround us. And then in that aspect, we will come more to, well, certain products will just help us mitigate these impacts more. And it could be that we need to maintain them differently, just differently. Sometimes it's not even more work. It's just different from how we know it. And I think once we've taken that turn, we can get used to it very quickly. But I really feel like it's really at this very critical moment where we need to make decisions for our well-being. Yeah. Yeah.
Awesome. All right. Well, I know we're a bit over time, but is there any last minute, anything before we end out today's session?
Maybe on the same note, Sophie, I have a question for. So when we design for disassembly, what would be the incentive for the client or the developer to pay for the potential additional cost? That's the first from the client or developer side, and from the buyer's perspective, can you give us an insight in the cost comparison to reclaimed materials, for example, the reclaimed glass versus a glass we can buy from a manufacturer. So from the two sides, what does it look like in terms of cost, and what would be the incentive to justify the additional cost? Thanks.
Aria, 1 minute is okay. Thanks. Not surprised by the great question, the great level of question. So I would just say quick, really selling people on the lead times would be a great idea. So for our partitions, you can have the partitions faster if actually they come from the inventory that we're retrieving. By the way, let me say, if anybody wants those partitions they're ready for being sold and reinstalled. So we're gonna go faster. And then in terms of design for disassembly, I would just, try to find parallels telling people that, hey, you're gonna have an easier, almost like a car, you're gonna be easier to maintain kind of system. So really have this extension of life is almost like getting a really good, robust car that's gonna have, take you further. So really kind of like trying to sell folks on the kind of extended life performance, kind of side benefits is going to be key. And everybody likes a good deal, that's a great idea. And then if also maybe in the future you can also start to bring in, biomaterials, maybe it start to do that hybrid system. There's an opportunity to kind of like perpetuate the system as the technology advances or realizes that, it's not necessarily advanced, but we had the solution from the start. So I think modularity will help. Maintenance, modularity, lead times are going to be key. And it might be a premium at the level of just the person buying it. But if you look at the full chain, like once we have storage taken care of, once we have, taken care of at the scale of a city, if you look at the total cost, it's not more expensive. It's cheap to send stuff away, but you have to deal with it later.
Right. Yeah, thanks. I think back home growing up, I used to see the shops where I'm from Ethiopia, Addis, and because the cost of materials, we import almost everything, so it's very expensive. So reclaiming materials, for example, windows, is very common, and it's you find these shops where you can stroll around, find window that fits your design, and then get it from there. Of course, it's not very well documented, but typically when you want to build cheap, you stroll around these parks, pick the material you want, and try to merge them together. But yeah, I'm always curious in a world where the labor is very expensive, how we work through that. And yeah, but thanks. Interesting ideas.
And you can do this in the US right now. I was in San Francisco, the reuse people warehouse last week, and I found a window that kind of fits the one from my house, and it's going to be a fourth of the cost. So this is already there and exists. You can shop today.
There you go.
Here you
Yeah,
go.
yeah.
Everybody likes a good
Thanks.
deal.
Yeah. Fantastic. All right. Well, I think we're going to end it there. But thank you so much. Thank you to all of our speakers. That was really, really insightful content and absolutely wonderful to have you all. And thank you all in the audience for attending. We will have this recording published somewhere, and I will send out, or we will send out from CLF or SFE where to access it online. But yeah, and keep a lookout for the future CLF and SFE events. But thank you all.